All right, hello and welcome to your lab tutorial. Today we're going to be talking about how to use Excel and kind of some advanced beginner techniques on Excel. Now, to talk about this lab, we're going to actually use an example of, we're going to talk about Station 5, our Excel data manipulation lab. So in here, we're given a problem where we've got this balloon, it's filled with some nitrogen at a constant temperature. We're given how much nitrogen has been filled into the balloon. We know what the temperature of the balloon is, and we know that the volume's changing. So we're going to then ask you to download some information from the lab website and create an Excel file to determine the radius of the balloon filled when this gas filled with this gas at 1 atm of pressure. And so we give you some directions here on how to do that. However, I'm going to kind of walk you through some more steps on how to do this, maybe a little bit simpler. So before I ever begin doing anything in an Excel assignment, I always first try to write out exactly what I'm trying to do. So I'm going to go ahead and start writing up my equations here if my software would ever work. Okay, so I know that I'm given a certain kind of information and I'm trying to now figure out another piece of information. So I'm starting out with radius information. And my radius information from that data file looks like this. And my units here, I don't have them written in. I should really do that real quick while I'm thinking about it. It is in centimeters. So now I've got my units there included. I can go back and how I'm going to be thinking about this. So my radius is in centimeters. I've got to somehow convert this radius of my balloon into some useful way where I can figure out what the radius is going to be given a different pressure. Well, I know that from the radius of a balloon, I can figure out the volume of a balloon. So I'm going to go from my radius to my volume. And if I do that, every time I've got an arrow here in my little flowchart, that indicates a step that I'm going to have to do. I'm going to have to manipulate the data in some way, or transform the data. Really, I'm not going to manipulate it. I'm going to transform it into something else. So I can convert, if I'm assuming that my balloon is a sphere, right? A nice little sphere there. I know that the volume of a sphere is equal to 4/3 pi r cubed. So if I've got my if I've got my radius, that can go right in here, and then I can kick out volume data right up here. Kind of nice. Now, if I know my volume, and previously it told me, the problem told me that I know my number of moles, and that wasn't changing. So I know my number of moles, and that was, let's see here, that was 0.01. So 0.01 moles. And I know that my temperature, because that's what it gave me, and I think that was 80 degrees Celsius, right? Yep, 80 degrees Celsius right up here. So 80 degrees Celsius. Okay, so given that I now have a volume of my balloon, I've also got my number of moles, I've got my temperature. I can remember that I've got this universal gas constant, which is always, constant, which has a couple different forms. But since I'm using volume here and I'm going to be dealing with a gas, I'm going to take the form that is usually looking like this. So it's the 0.08206 atmospheres times liter per mole per Kelvin there. And with volume, number of moles, temperature, and R, I can remember my ideal gas equation. Whoops, there. PV equals nRT. Yeah, quite nice. So if I've got my volume, if I've got my moles, I've got my temperature, and I've got my gas constant, I can figure out the pressure of my balloon at these different radii. So I can figure out my pressure, which is quite nice. So then I've got to stop and I've got to ask myself, okay, what am I going to do with this pressure? Well, I know that pressure and volume has a relationship, and I know from the problem, let's go look at that again here. It tells me that I'm going to use the ideal gas law, and I'm going to calculate the pressure and atmosphere at each volume. And down here, I'm going to make a plot of my data and use a trend line information from my plot to come up with this linear relationship between something. And then the something here is going to be my pressure and volume. So I'm going to, as my next step from here, I think, okay, I'm going to make a graph. And from that graph, I'm going to get a trend line. And from that trend line, I'm going to be able to figure out my final answer. So that's a lot of steps to go ahead and start with. So why don't we go over to Excel and kind of start working some of this information up now. Okay, so I'm going to actually first put up here in this first cell my name. Kind of, every document should have name in there. Let's see if we can figure out a way to zoom this in too here. Zoom 100? Sure, why not? That's great. So with that radii, as I wrote down on the little equation sheet there, I can convert that radii into a volume. So I'm going to say volume. And I had that equation 4/3 pi r cubed. So I'm going to go ahead and say now, all right, I'm going to set an equation to solve for my volume. And when I do this, to start an equation, I hit the equal sign, and then I start typing in my terms. So 4/3, and then I'm going to use as pi 3.14159, because I roll. And then for my r cubed, well, that would be my radius. So I'm going to click here to... Yep, we're going to accept that autocorrection. So I had to put that little multiplication symbol in there. And so I'm going to then put the little multiplication symbol here, and I'm going to click on my radii. And in order to cube it, I could just multiply it by 3 times, or I could use the little raised caret here, and then to the third. And then when I hit enter on that, it goes ahead and cranks out a volume for me. But what unit is my volume in? Well, I started out with centimeters here and I just cubed them, so my volume here would really be in centimeters cubed. So centimeters cubed. And now that formatting doesn't look very good. Yeah, that 3, I should really do something else with that. I'll fix that here in a little bit. Now, I also want to kind of resize my cells. So I'm going to click and drag that over here so it's a little bit easier for me to read. I'm also going to select this information. I'm going to go home, and I'm going to center it. And I'm going to resize this volume cell. I'm actually going to click up here, and instead of dragging, I'm just going to double click right there, and the computer will do all the resizing for me. And I'm going to center that information. Great. Okay, so that's my volume. I did that for one cell. I can go ahead now have Excel calculate all the information for me. So I take my cursor and where it goes from being the little white cross to then being the black cross. Now I'm going to double click, and it fills all the way down for me quite nicely. Okay, so then the question is, how am I going to take, if we go back and look at our equation, how am I going to take my volume and convert that to a pressure? Well, let's stop and think about this for a second. I've got my ideal gas law, PV equals nRT. But to do this, I need my volume to be in what units? Well, if I look at R tells me all the units of everything in my equation. So I need atmospheres, I need moles, I need Kelvin. I also need liters right there. Okay, so let's go ahead and let's convert our volume into liters. So going back into Excel, I'm going to remember my conversion of centimeters cubed, and I'm going to remember, okay, 1 centimeter cubed is equal to 1 milliliter. Well, actually, let me go ahead and just write that out. So 1 centimeter cubed is equal to 1 milliliter. And then I can say 1,000 milliliters is equal to 1 liter. So if I've got my unit here in 1 centimeter cubed, actually I had, what was that? Like 250 centimeters cubed. Okay, well, if I want to convert that all the way out to liters, well, that's going to be 1 centimeter cubed is equal to 1 milliliter. And I'm then going to say, all right, well, 1,000 milliliters is equal to 1 liter. And so then my units here cancel, and I'm left with my answer. But I'm not going to calculate this by hand for every single one of my values. I'm going to take a look, and I'm going to see what numbers actually changed. And I'm going to build an equation in Excel to handle that. So what it ends up looking here is I'm going to take my volume measurement in centimeters cubed, and well, here this was effectively multiplying by 1, and here I'm dividing by 1,000. So I'm going to take that volume and I'm going to divide it by 1,000. So if we go back into Excel, all right, I'm going to now set up a volume in liters. And so I'm going to equal sign there, the cell right here divided by 1,000, and bang, I've now got all my volumes in liters. I'm going to double click. That fills all the way down. I'm going to come up here, click that. Oh, that nicely goes ahead and formats things for me. It's very good. And in fact, you know, I said I was going to make that 3 a superscript earlier. Because that centimeters cubed is the same thing as milliliters, I'm just going to convert that here to milliliters. So the thing I'm going to be doing now is solving for pressure. So I'm going to go ahead and call this pressure. Take out one of those S's because it's not got 3. And that's an ATM. Okay, and I'm going to just double click that because I'm formatting. And I'm going to go ahead and start writing out my equation now for pressure. So if I go back to my sheet, I can rearrange my ideal gas law here and say pressure is equal to my number of moles times R times T divided by my volume. Okay, so let's go ahead and let's convert our temperature and everything into the appropriate units. So my number of moles there, that's nice, that's already in moles. So that 80 degrees Celsius, to get that into Kelvin, so 80 degrees Celsius into Kelvin, I'm going to need to add 273. So 80 degrees Celsius and my 273. So I'm going to, right? Here's hoping. Okay, so that's my Kelvin temperature. So I've effectively got 0.01 mole times 0.08206 liter time the atmosphere per mole time Kelvin. I'm running out of room here a little bit, didn't think about that. Times 353 Kelvin divided by my volume. Well, my volume is going to change every time, but I could just go ahead and say that volume there equals my pressure. Oops, that's an R. Pressure. There we go. So this is a number, this is a number, that's a number. This is a number that's in my Excel sheet, so I could just make my equation out of that too. So we can go back over here into Excel, and we can say this is going to be equal to 0.01 times 0.08206 times 353. And then divide by my volume. And when I do that, I get my pressure. So I can double click and drag that on down. Fantastic. Okay, let's look and see what that kind of relationship I have now is if I make a graph out of this. So if I select these two sets of data and I'm going to insert a graph, and let's do an XY scatter. Here we go. Okay, so first off, before we really even can analyze the data, we should make this graph look a little better. We've got all this empty space right over here and a little bit over here. So I'm actually, I'm going to change my axes. So I'm going to double click and this formatting box shows up here on the side. So I'm going to change the minimum on the axis to be 0.02. So 0.2, misspoke there, 0.2. If I do that, it's going to cause this graph to fill in and take up a little more space, which is great because there's really no point in having a bunch of empty space there. In fact, I'm going to kind of shrink this in a little bit more. I'm going to put a 0.24 in, and that might make things, yep, that makes everything so much better here without cutting off any of the data. And so I'm then going to go ahead and say, oh, well, I've got all this empty space on my y-axis. I'm going to click on my y-axis, and now all the formatting options have shifted over to be for my y-axis. My last data point seems to be about 0.04, so I'm going to make my minimum 0.4. Keep adding a 0 in there, don't know why. All right, and then if I do that, great. Now my data is taking up most of my graph, which is fantastic. If I right click in here now and then I say add trend line, and I say add a linear trend line, cool, that's what I'd want. I always want to display my equation on the chart. I also want to display my r-squared value. All right, and when I do that, and I'm going to go ahead and select these little lines here, try to get rid of these, and this one too, just for aesthetic reasons. So when I do that, I see that I do get a trend line, but I also get an r-squared value that's not exactly 1. We'd like r-squared to be 1 if at all possible, and it's not. Another thing that should be going off in my head is the fact that pressure and volume don't have a relationship that it works like I've got it graphed. I'm trying to plot pressure and volume directly. They're inversely proportional to one another if we remember back to our General Chemistry 1 days. So I've not actually quite set this up in the way that I would want to. I'm going to keep this graph up here, but I'm going to kind of shrink it down here a little bit and move it off to the side because I need to do a little bit more with my data. Okay, so I'm going to select my data and I'm going to cut it and I'm going to actually paste it one cell over here. Gonna space that out. I'm going to go ahead and put in my 1 over volume cell now. So it's 1 per liter. Okay, and this is going to be equal to 1 divided by this box. So now I can go down here and I can double click. I can double click, autofill that in. And so whereas this was pressure versus volume, I'm gonna go ahead and get rid of that ATM. If I grab this information now and I insert XY scatter, okay, and I'm gonna kind of shrink that over here a little bit. I can already see this data looks a lot more linear, which is great. I'm going to double click here, going to change my axis. I'm going to have it start at about like 1.5, I think. 1.5 that is. And I'm going to have it end at about 5. And that is 1.5. Thank you very much. And all right, that's filling up. And I'm going to go ahead and actually drop that down to 4.5. Super. Just trying to fill in as much space on my graph as I can. I'm going to select my y-axis and I'm going to say, okay, well, that's minimum should be 0.4 and the top here should probably be 0.12. And it did that for me already. Fantastic. Great. That definitely takes up all the space that I've allotted for it. Fantastic. Now this is not pressure versus volume, this is pressure versus 1 divided by volume. That's important. Let's go ahead and get rid of that unit in there. Let's add in our trend line. So we can right click, we can add trend line, that's what we want, add trend line. Display equation on chart, display r-squared value, and when we do that, look at that. That is fantastic. Now we have an r-squared 1 plus we have the relationship that's actually correct. We have pressure being related to the inverse of volume. So that's really nice. Now, I personally just like to get rid of lines because for me, they kind of look like you can do what you like. But I'm not done formatting this axis or this graph yet. I'm going to need to put in my axes. So I'm going to go up to quick layout. So let's see here. I've selected the graph, so I'm on chart tools and design, quick layout, and there we go. If by just doing quick layout in this very first option, layout number 1. It's nice because it puts in my axis title, I don't have 2 sets of data going, so I'm actually going to select that one, get rid of that so it fills up the most of the space. Going to select these, get rid of those again, and now I can fill in my axes titles. So I'm actually, since I know that this is not the right relationship anymore, I'm going to go ahead and get rid of that graph because I don't really need it. I'm going to keep this one. And it took away my trend line. Oh noes. So let's go ahead and put that back on there. Great. Fantastic. Value. Fantastic. Here we go. So which axis is which? All right. Well, if you're like me, you sometimes have difficulty remembering which way Excel plots things. So I always look at my data, and so right now on my y-axis, my data set is between 0.4 and 1.2. So I go over here to my data and I say, oh, well, this is 0.5 and 1.12. Oh, okay, or 1.15. Okay, that matches the data that's here on my y-axis. So I'm gonna put that in here. I'm gonna call that my pressure. And I'm gonna make sure I put my units in there. Atmosphere is fantastic. If that's my pressure, that this means that the x-axis is my 1 over volume, and that's going to have units of 1 divided by liters. Super. Okay, oops, don't want that. All right, and that's my graph. So what do I do with that now? Well, with my graph and now having my trend line, if I know my volume, then I can calculate any pressure along that line. Likewise, if I know a pressure, I can calculate any volume I have. Oh, so let's go back now to our little equation sheet. Okay, so we said when we get to the trend line, what do we do? Well, it's a little clearer to me now, because now with that trend line, if I know my pressure, I can take my pressure and I can insert that pressure into the trend line. And when I do that, I get out a volume. And if I get out a volume, I know how, because back here I took a volume and got that from a radius. So I'm pretty much working in the exact reverse order. I'm taking a volume and I can then convert that into a radius. So we can go now into Excel here, and let's start asking ourselves, okay, what does each term mean? Well, y is my pressure, x is my volume. So I can say, I can take this information and now use it to calculate out my volume of my balloon that the problem gave me. Let's go look at the problem again. Right here where it said determine the radius of a balloon filled with this gas at 1 atm. Well, now I know my pressure. I can insert this value of my pressure into that equation from Excel. Like right in here, I can put it in for y. Okay, so I'm going to grab my equation here and I'm going to copy it. Okay, well, I'm just going to hit the shorthand, so Control C on Windows. I'm going to put that over here. This is kind of getting a little confusing. So I'm going to go ahead and get rid of this information now. Let's see here. So we're going to copy and we're going to put that in like that. And so again, we said that pressure was our Y value up here. So this was pressure and this was 1 over volume. So we can then rearrange this equation here a bit and we can say, okay, y plus 1 times 10 to the negative 15th, because that's what this value actually is, equals 0.2897 times x. And then we can isolate, well, actually at this point in time, we could go ahead and say, okay, well, we know what the value of y is. We know that it's 1 atm. So 1 plus our 1 times 10 to the negative 15th divided by equals our 0.287 x. We could go ahead and we can have Excel go ahead and calculate that information for us. Before we do that, though, let's go ahead and let's get rid of this from both sides. 287. So we divide, and then go ahead with this, and then 0.2897. And so then we have x isolated as 1 plus 1 times 10 to the negative 15th over 0.2897. And this 1 times 10 to the negative 15 is ridiculously small, but that's okay. We're going to go ahead and calculate what that is in Excel anyways. So back to our Excel. So we're going to go ahead and we're going to say this is going to be the 1 over volume when pressure equals 1 atm. So equals that equation that we had. So 1 plus 1e to the negative 15. See here, divided by our 0.2897. And so we end up with a value of 1 over volume equaling that. But that's 1 over volume, and that's not really what we want. What we really want is volume. So how do we get rid of the 1 over volume? Well, we can take the inverse of that number. So our volume here, and because we did volume in 1 over liters, volume, when we solve for actual volume, will be liters. So we can say that's equal to 1 divided by this value. And we can hit enter, and there we go. That's our volume in liters. And now we can kind of work in reverse of what we did here. Before we had to divide to get our milliliters into liters. Now we're going to take that volume in liters and to get that into milliliters, which is the same thing as centimeters. We go equals this guy times 1,000. Yeah, 1,000. And so that gets us our volume now in milliliters. And so we can go back to our little drawing board here and we can say, all right, so volume of a sphere was equal to 4/3 pi r cubed. Now we're trying to solve for that one. So let's go ahead and let's isolate off as much as we can. So let's take both sides and let's multiply both sides by 4/3 to get, I'm sorry, 3/4 to get rid of the 4/3. So that'll cancel that, that'll cancel that. And so then we get 3/4v equals pi r cubed. And so then we can divide both sides by pi. And so we get our pi over here. And so we get with our, oops, I forgot division symbol there. So 3/4 volume times 1 over pi equals r cubed. Now to get rid of that, we could do the cube root on both sides, or we could raise both sides to the 1/3 power. And I'm going to go for that last part. I'm going to raise that to the 1/3, and that would cancel that out. So then I'm going to raise this entire side to the 1/3, and that'll cancel out. So r is equal to 3/4 times volume times 1 over pi raised to the 1/3. And that's the way I think about it. I'm sure there are other ways to think about it. This is just what I do. So now it comes incumbent upon me to translate that equation into my Excel sheet. So I'm going to grab Excel here, and I'm going to actually take Excel and make it just this one side of the equation here, or I'm sorry, one side of my screen. And I'm going to try to click and drag this side. Yeah, try to click and drag. All right, so that's the equation that I want right here. This is what I'm going to try to mimic into Excel. So I'm going to go over here to Excel, and I'm going to then say my radius in centimeters is going to be equal to, and here we go, 3 divided by 4, close that parenthesis, so that's my 3/4, times my volume, which is right here, right? And then times uh, 1 divided by 3.14159. Okay, so that's my 1 divided by pi. And so then I can close my parenthesis and see how Excel does this nice job of letting you know, okay, this set of numbers go in this parenthesis, this one goes in this one, and the black ones there. So Excel just try to help you out. And I'm going to raise this to the 1 divided by 3 power, and I hit enter, and there's my radius. So I have now successfully, I'm going to make this full screen. I have now successfully solved for my radius at this point in time. So I can go in and I can do a lot of little neat things here, make this look all pretty and beautiful and such, which I would recommend going ahead and getting used to doing a little bit of formatting for certain things. And let's go ahead and I did not have this in sig figs, so I could do that later, but I'm going to select that and make that yellow so that it indicates the number to the reader. And so I could even say down here, okay, or I can go back and read the original document and I can say, okay, how many sig figs do I need? And I can figure that out. Anyways, that's a big video about some ways to use Excel, make your life a little easier. Please let us know if you have any questions. And thanks so much for watching. Good luck in lab.